Hello, welcome and thank you for tuning in to a Risk Management Professional webinar. My name is Joyce and today we will cover the Offsite Consequence Analysis. Before we jump into our topic for today, here are some of the key services we provide at Risk Management Professionals, as well as our background, qualifications, location of office, and contact information. Now, Offsite Consequence Analysis, or OCA for short, assesses the distance a chemical release will travel before personal exposure to hazards is no longer likely. There are two types of chemical releases. One is toxic substance, which will lead to personal exposure to toxics, and there is flammable substance release, which will lead to personal exposure to fire. Offsite consequence analysis, also known as hazard assessment under CalOp, RMP, and PSM, is required no matter which program level your process belongs. For more information on what CalOp, RMP, and PSM are, the differences between the three, and what each program entails, please refer to my previous webinar titled RMP, PSM, CalOp Program Development via rmpcorp.com. With that being said, we will now go over the two types of offsite consequence analysis. One is worst case scenario, and the other is alternative release scenario. The worst case release scenario is usually the loss of the total contents of your largest vessel or process line, although some exceptions may apply, such as the dispersion of toxic gas. What determines a release being the worst case is that the impact could travel the furthest and can affect the greatest number of public receptors or population. On the contrary, alternative release scenarios are more likely to occur than worst case scenario. In some cases, this may be a flange leak or a piping leak. Per EPA's guidelines, alternative release scenarios considered should include but are not limited to the following where applicable, such as transfer hose release due to splits or sudden hose uncoupling, process piping releases from failures at flanges, joints, welds, valves and valve seals, and drains or bleeds, process vessel or pump releases due to cracks, seal failure, or drain, bleed, or plug failure, vessel overfilling and spill, or overpressurization and venting through relief valves or ruptured disc, and lastly, shipping container mishandling and breakage or puncturing leading to a spill. And all these examples will be dependent on the facility and its operation. So not only is the offsite consequence analysis or hazard assessment required under the EPA, RMP, and CalArp, it also helps us determine which program level our facility belongs. The differences in program levels mean differences in the requirements needed to be fulfilled. Some of the critical factors which determines a facility's program level includes 1. Proximity to public receptors upon a worst-case release scenario, which is determined through dispersion modeling. Second is the occurrence of off-site impacts with a regulated substance. This is whether there have been accidental releases previously or are accidental release records. Thirdly is whether the process is subject to OSHA PSM standards and NAICS codes. This is determined by the substance used in our processes. Now, a key point to remember is that any process can be eligible for Program 1 even if it is subject to OSHA PSM or is in one of the NAICS codes. For more information, please refer to the General RMP Guidance document, Chapter 2, Applicability of Program Levels, which is also where this exhibit is sourced. As you may have noticed, we have been using the terms cover process when discussing program levels. The word process, as defined under 40 CFR section 68.3, is any activity involving a regulated substance, including any use, storage, manufacturing, handling, or on-site movement of such substances, or a combination of these activities. And the word cover process is basically that, but the process contains a regulated substance that exceeds the threshold quantity that is either established by OSHA, EPA, or CARB, depending on which one you exceed or where you are. Now, in terms of storage tanks, processes that are stored in these vessels can be defined and separated by the following. One is that they are not tied via a connection, such as a hard pipe, and that they are stored and located sufficiently apart from each other. And for more information on how processes are defined and divided, please refer to Chapter 1 of the General R&P Guidance. I believe Chapter 1 is General Applicability, and it has an Exhibit 1-2 that contains the more information or detail on how your processes can be divided or separated. And if you have any questions on how to define the processes in your facility, please also feel free to contact us at rmpcorp.com and email us for any questions you may have, and we can help you define your facility processes accordingly. So now that we've defined our cover processes as well as determining our program level, we can do the following items listed here to stay in compliance depending on your program level. So firstly, you must do one worst case release scenario for each program 1 process. Next is you must do one worst case release scenario to represent all the regulated toxic substances in your program 2 and 3 processes. Likewise, you must conduct one worst case release scenario to represent all the regulated flammable substances in the program 2 and 3 processes. Now, you must do one alternative case release scenario for each of the regulated toxic substances in your program 2 and 3 processes. What this means is that if you have 3 different regulated toxic substances, you must do 3 different alternative case release for each of the toxic substances you have at your facility. But differently, you must only do one alternative case release scenario that represents all the regulated flammable substances in your program 2 and 3 processes. What this means is that if you have 3 different flammable substances, you only need to report one alternative case release that will cover all 3 flammable substances. And what this basically means is choose the flammable substance that has the furthest distance to the endpoint upon a worst case release or upon an alternative case release, and using that to represent all of your flammable substance. Right? And please note that for program 1 processes, you only need to do worst case release. You do not need to consider alternative release scenarios, nor do you need to report those. And if you have a program 1 process that contains multiple chemicals that are regulated, you will need to do a worst case release analysis for all of the chemicals, but you only need to report one of them. And we'll go into this in more detail in just a little bit, but this is just an overview of what you would need to get done for your process depending on which program level you belongs. Let's go ahead and do an example. So, starting here, we have a storage tank that contains a regulated substance that exceeds the threshold that is established by either OSHA PSM, EPA R&P, or CARB. And then we conduct a worst case release scenario for our storage tank here, which is usually the rupture and release of the entire capacity of the storage tank. And with that, we draw out the area of impact from our worst case release scenario, and we want to see if we are eligible for program level 1. Just as we thought that we can be eligible for program level 1, we realized that within our area of impact for the worst case scenario, there is a school. And because of that, our process is not eligible for program level 1 because our worst case scenario reaches a public receptor such as a school. Public receptors can include, but are not limited to, the following: off-site residences, institutions such as schools we just mentioned, hospitals, industrial, commercial, office buildings, parks, and recreational areas. Please note that public roads and bridges are not included as public receptors. Nevertheless, a facility should coordinate with local emergency planning and response organizations to address any potential accidental releases. For most facilities, the meaning of the definition of public receptor is pretty straightforward. If you restrict access to your property at all times, public receptors are any occupied buildings or public gathering areas beyond your boundaries. Access restrictions can include precautions such as a fully fenced site, security guards on duty at a reception area, or ID badges that is required to gain entry to the facility. If you have unrestricted sections of your site that are predictably used by the public, such as a ball field or picnic area, then these sections would be considered public receptors. Neighboring businesses, whether commercial or industrial, are considered public receptors, as are residences, institutions such as hospitals, schools, prisons, marinas, and airport terminals, public and private parking lots, golf courses, transit stations, and toll booth plazas for roads and bridges. The ability of others to restrict access to an area does not change its status as a public receptor. However, not all areas off-site are public receptors. Public roads and bridges, like we mentioned, are not considered public receptors. For other areas, you need to make a reasonable determination as to whether the public is likely to inhabit or occupy an off-site area. For example, a facility located in a remote mountainous area surrounded by unimproved forest might reasonably determine that the surrounding land is not a public receptor, even if it is infrequently traversed by hunters or fishermen. If a remote facility borders a park or wilderness area, the parts of the park, such as the campground, picnic area, or hiking trails that are likely to be occupied by the public, even if only seasonally, would be considered public receptors. Farmland may or may not be a public receptor. If farm workers are usually present, the farmland is a public receptor. If, however, the farm or ranch land is rarely occupied by workers, it may not be a public receptor. At the end of the day, if you are in doubt whether to consider certain areas around your facility as public receptors, you should consult with local emergency planning officials, local or state authorities, the landowners, and or implementing agency for guidance on whether such areas should be considered as public receptors. All right, now that we did an example, let's just take a quick look on what kind of facilities have a higher eligibility for program level 1 and what kind of facility are likely not eligible for program level 1. So if your facility has the following, you may likely be eligible for program level 1. One is if your process is not close to any public receptors. So if you're in the middle of the wilderness with very little public receptors around, you may be eligible for program level 1. Another is if you store toxic gases in enclosed areas, which would help prevent it from going far enough to reach a public receptor. Or if you work with toxic liquids that are stored in diked areas, or upon release would be released in a diked area. And some of these toxic gases and liquids are listed here in the slides. I won't go through every single one of them, but typically your eligibility for program level 1 will be highly dependent on what kind of chemical you're working with, and how your storage setup is established. So if you have dike areas for your tanks, or if your tanks are stored in any enclosed buildings or whatnot, can also greatly reduce the likelihood for your worst case scenario to reach an offsite public receptor. On the contrary, some of the processes that are likely not eligible is if you say have any public receptors within 0.5 miles from the process. Typically, that makes it very difficult for your worst case scenario to not really reach your public receptors unless you're working with, say, a very say you're working with materials that doesn't really disperse all that well, then sure, there's potential for that. But if your process is located relatively close to, say you're located in an industrial area, then that kind of it makes it more difficult to argue for program level 1. So that's kind of the typical gauge. Next is if you, kind of like I said before, if your facility is small, has a small acreage, and you're also in developed areas, that means you could be very close to other facilities, and thus they are public receptors around you. And if you have a small acreage, then you have a high likelihood for a release to go offsite. Another one is if you work with toxic gases or liquid under pressure. So when it's released, it has a high likelihood to go a lot further than you would expect. So that's something to keep a note on too. Same thing with refrigerated liquid chlorine and any toxic liquids that's held at elevated temperatures. But with that all being said, there's always exceptions. There's just a kind of like the typical gauge for you to assess or check to see if you may be eligible for program level 1. The rule of thumb is to always conduct a worst case analysis to determine whether your worst case release scenario will hit a public receptor or not. And the whole reason why we even talk about this in the first place is that if your facility is eligible for program level 1, you should really try to keep yourself in program level 1. This is not to say that you should start making things up for how far your worst case release scenario will go or how far it will reach. But if you can keep yourself under program level 1, it will remove a lot of other unnecessary, or I shouldn't use the word necessary, but a lot of other regulatory requirements that may be harder to manage or will provide more or cause more confusion to your facility as you're trying to maintain the program. So if you are eligible for program level 1, typically even counties will encourage facilities to do worst case release scenarios to check if they can be in program level 1, and if they are, then they should. So that's just some insights on program level 1 eligibility. Now, just a recap on program level 1 eligibility. So if your process is currently categorized as a program level 1, or you believe your process may belong to program level 1, it must fulfill the following criteria. One is that there are no public receptors within the distance to the endpoint from a worst case release. This is, like we said earlier, with a worst case release scenario, doesn't hit any public receptors, no school, no parks, nothing that will fall within that area of impact. Second is that there are no accidents with specific offsite consequence within the last 5 years since the RMP submittal. So within the last 5 years prior to your RMP submission, there were no release of regulated substance that led to an offsite death or environmental impact. If that's the case, then you're good for point 2. And lastly, you must fulfill this last criteria, which is that you have coordinated your emergency response activities with the local responders. And just to note that this requirement not only applies to program level 1, but it also applies to any cover processes regardless of program level. But just to note that even in program level 1, you must make sure you have coordinated emergency response with local responders. So here I wanted to give another example to what you should do if you are under program level 1. Say you have 3 processes, one that has a regulated chemical number 1, regulated chemical number 2, regulated chemical number 3, each with different worst case release radius of impact. So just to make sure that you can prove yourself to be a program level 1, you can prove that your processes are under program level 1, you would need to do a worst case analysis for all of these regulated substances. Nevertheless, you only need to report one of them. If your processes are program level 1s, you would only need to report the substance that has the largest area of impact. Therefore, because we have these 3 substances and they each have a different worst case release radius of impact, you report the one with the largest area. So since our regulated chemical number 1 has the highest radius of impact of 1 mile, you report that one only. Still, you should complete worst case release scenarios for all of these chemicals to be able to prove that you are eligible for program level 1, but you only need to report one of them. Now that I think we've pretty much exhausted everything we have to talk about for program level 1, let's go ahead and jump into program level 2 or 3 processes with an example. So let's say you are a facility that works with the following regulated substances: 3 toxic chemicals with different radius of impact for the worst case consequence, as well as 3 different flammable chemicals with different radius of impact for worst case consequence. With these 6 regulated substances in place in the facility, how many worst case analysis and how many alternative release analysis would we need to do for this facility? Take some time to guess, come up with an answer, and I will reveal the results momentarily. All right, hopefully everyone got it right. What you'll have to do for this facility, working with these chemicals, is to identify, analyze, and report the following. 1 worst case scenario for toxic chemical number 1. And this is because toxic chemical number 1 has the furthest radius of impact. So we report the worst case scenario that covers all the toxic chemicals. All right, but separately, you must also do 1 worst case scenario for flammable chemical number 1. So this is the worst case release leading to the worst impact case for all flammable chemicals in the site. So you also only need to report 1, but the one with the furthest area of impact. All right, and now this one's a little bit different, but you must also report 4 alternative release scenarios total. There will be 3 alternative release scenarios for each toxic substance here, 1, 2, and 3. But you only need to do 1 alternative release scenario that will represent all flammable substances. So depending on which flammable chemical goes the furthest, it may be chemical number 1, it may not be. You'll have to do an alternative release analysis to see which one goes the furthest, but the one that goes the furthest will be the one alternative release scenario that represents all the 3 flammable substances listed here. So those are what is required for reporting, and you may have to do more analyses depending on whether to determine which one goes the furthest, say for worst case, and or if the alternative release scenarios are going to be different than the worst case. So you don't want to assume that because flammable chemical number 1 has the furthest worst case release scenario that it would also be true for alternative release. You want to make sure you submit the one that has the furthest area of impact, at least for flammable. But for toxic, you have to do alternative release for every single one of them. But for worst case, it's the worst possible impact, and you just separate by toxic substance and flammable substance. So you do a worst case release scenario for each type. So before I move on to the next part, I just want to give a quick clarification on the one worst case scenario for toxic and for flammable substances section. There are exceptions to this requirement, which is that if you have another chemical that, say, affects different public receptor than the one with the largest radius of impact, then you would need to include that worst case analysis as well. So one potential example of this is if, say, you have, right now with this example, you have toxic chemical number 1 with 1.0 mile radius, and the storage tank for toxic chemical number 1 is located in the center of the facility. Now let's also say that the facility area is 0.8 miles from that center, the same location where your toxic chemical number 1 is stored. And now let's say we have toxic chemical number 2 stored at the by the border of the facility. With that being said, now you have toxic chemical number 1 having a 1.0 mile radius impact, which would go offsite by 0.2 miles. But now you also have this second toxic chemical number 2, that is by the border of the impact, which can actually reach 5 miles out offsite. And because of that, it could affect different public receptors compared to, say, toxic chemical number 1. And if that is the case, then you will need to report the worst case release analysis for both toxic chemical number 1 and toxic chemical number 2. And I know this might sound a little confusing, so if you need more clarification on this, just please feel free to reach out to me anytime via email, and I'll show my contact information at the end of the slides. But basically, the rule of thumb is that if you're typically your one representing worst case analysis is typically the one with the greatest radius of impact, but in case you have another substance that affects a different public receptor or different area that has different public receptors, then you need to include that as well. And this is the same for flammable worst case release. So I know we've been saying toxic substance, flammable substance, but what exactly defines whether a substance is toxic or flammable is really determined by the list of substances from 40 CFR section 68130. And within that list, it provides the basis for why a substance is listed as toxic or flammable. So the basis for listing for toxic substances are the following. One, that is mandated for listing by Congress, or that on the EHS list, vapor pressure is 10 millimeter of mercury or greater. And next is that it is a toxic gas. Next is that the toxicity of hydrogen chloride, potential to release hydrogen chloride, and history of accidents. So there are some substances that is based on this ability to release hydrogen chloride, as well as previous records of historical accidents. And in a similar manner, the toxicity of sulfur trioxide and sulfuric acid, any chemicals with potential to release sulfur trioxide, as well as previous history of accidents in other industries or in other manufacturing facilities back in the past. So all of that are a basis for why a substance is listed as toxic. And for flammable, the basis for listing as flammable substance is, one of course, is that it was mandated for listing by Congress. And if it is a flammable gas, then it's pretty apparent that it would be a flammable substance. And likewise, if it is a volatile flammable liquid, that's also a pretty clear indication for why a substance would be listed as flammable. But with all that being said, it's usually pretty clear on the list of substances whether that substance is toxic or considered toxic or flammable. The thing with this categorization is that if we're working with a regulated substance and it is listed under the toxic substance, then you conduct the analysis according to how you would conduct for analyses for toxic substance. So the whole one worst case scenario for all toxic materials and one alternative scenario for each of the toxic substance. And if you found your chemical under the flammable list, then somewhat likewise is you would do one worst case scenario for all flammable substances in your facility, as well as just one alternative release scenario that covers all flammable substances. But this is mainly for gauging what you have to do for your hazard assessment or offsite consequence analysis, depending on which type of your regulated substances it belongs, whether toxic or flammable. I have an example here. If you refer to the Codes of Federal Regulations, section 68-130, you'll see the substance. If you scroll down, you'll see the basis for listing, and it starts with 2 tables of toxic substance, and then after that 2 tables of flammable substances, and they're just listed in different orders. But if you refer to that table, it should be pretty clear whether a substance is toxic or flammable. And if you have any questions, feel free to reach out to anyone here at RMP Corp. We'll be able to help you determine what exactly is needed for your facility based on the substances or based on the regulated substances that you hold on site. So of course, like everything else we've done in this webinar, we'll do an example. So here we have the chemical cyanogen, which is a regulated substance. And per the hazard grading, it is 4 in health, which can be lethal. It is a flammability 4, which burns rapidly, or completely vaporizes at atmospheric pressure and normal ambient temperature. And a 1 in instability, which is normally stable but can become unstable at elevated temperatures and pressures. No special hazards aside from that. So since it is both a health 4 and a flammability 4, how will we know if this is a toxic substance or a flammable substance? And the answer is simple. Refer back to that list of substances that we mentioned earlier. So the answer to whether this is a toxic substance or flammable substance is simple. Refer back to the list of substances under 40 CFR section 68-130. Cyanogen is regulated as a flammable substance and thus should be analyzed as such. It is a bonus, although not legally required, to consider the toxicity of the substance. And as we can see from the health grade or the health level, even though it is a health 4, you are only required to treat it as a flammable gas and analyze the hazards associated with this chemical as a flammable substance. Now that we've discussed everything that has to do with program level 1 and 2 and 3, here is a table that summarizes everything we've talked about till now. So, if your processes are categorized as program level 1, you must do one worst case release scenario for each process. And in the process of doing that, making sure that none of your cover processes or regulated substances are going to go offsite and affect a public receptor. So that's for program 1. And if you're in program 2 and 3, or 3, you must do one worst case release scenario to represent all the regulated toxic substances in the processes. You must also do one worst case release scenario to represent all regulated flammable substances in the process. And then with that, you do one alternative release scenario for each toxic substance and one alternative release scenario to represent all regulated flammable substance in the process. And just a quick clarification for program 1. You do one worst case release scenario for each process to check that it doesn't go offsite and affect a public receptor, but you only need to report one once you've determined which one has the furthest area of impact. So say your facility have multiple regulated chemicals and they all fall under different program levels. So maybe one of your chemical is eligible for program 1 because it doesn't go offsite and it doesn't hit any public receptors. But you have 2 other chemicals that does reach public receptors, so they're either program 2 or 3, depending on whether you are under OSHA PSM regulations or not. So when you have different processes that all fall under different levels, what do? It's actually pretty simple. You just handle each chemical or each processes separately. So for chemical number 1, you would need to do one worst case analysis only. You don't need to do an alternative release scenario. You also need to do one worst case analysis to cover both chemical number 2 or 3, depending on which one travels further offsite, or both if they affect different public receptors like we said earlier. Alright, and lastly, you would need to do 2 alternative release scenarios, one for chemical 2 and another for chemical 3. And this is assuming that we are dealing with toxic regulated chemicals only. If it is flammable, then as we said before, then it would be one alternative release scenario to cover the 2 flammable substances. Alright, so in terms of CalARP or Risk Management Program, hazard assessment can include all 3 chemicals in the report so long as the program category is clear. You won't need to make 3 separate reports to cover each of the processes. One report, so long as it's clear, is adequate. Alright. Nevertheless, as you may know from my previous webinar, the RMP or CalARP program consists of multiple elements, and there's even more other elements if you are under OSHA PSM. So in terms of developing your other program elements, it may be best to handle them separately. But as far as offsite consequence analysis or hazard assessment is concerned, one report with all the listed chemicals, their worst case alternative release scenarios, so long as they're clear in the report, it is sufficient and oftentimes accepted. And I know we've been using phrases like offsite consequence analysis, worst case release scenario, alternative release scenario, but never really touch upon how exactly are these releases analyzed. So this is Exhibit 4-1. It's also from the General RMP Guidance from EPA. This is considerations for choosing a modeling method. So there are some approaches that you can take to assess your offsite consequence. First one is the simple guidance. This is per EPA's Offsite Consequence Analysis guidance. There's some advantage to this, so it is free. There's no computer requirements. Well, obviously, if you're accessing it from a laptop, then you would need a computer. But with the guidance alone, you don't need to download or purchase any dispersion modeling programs or modules. So there's no computer requirements there. It is simple to use. It provides all the data you need, and as well as tables, distances, and it eases compliance with rule. So pretty straightforward there. Some disadvantages to that, though, is that the results are oftentimes conservative and may be a lot further than the actual realistic case. There are also very few site-specific factors considered, so you may not be able to consider diked areas or enclosed buildings and things like that. There's also very little flexibility in scenario development, so there's only a few examples of, say, worst case is always going to be a rupture of entire tankage, and there's probably set amounts that are in the booklet, so you also maybe can't go exactly with the amount you have. You might have to round up, and things like that, as well as alternative release. Maybe there's only a few options. There might not be one that matches exactly to your facility. It's likely scenario. So there's lack of there may be a lack of flexibility in that case. Now, the second approach then is simple computer models, and this is what a lot of our clients go with, and it would generally be sufficient for most facilities. Examples of these include EPA models such as the RMP Comp or the Aloha software. The advantages of this is either no cost or low cost. As far as we know, RMP Comp or Aloha are all free softwares that you can download from the EPA website. And it's relatively simple to use. Instructions are typically pretty clear and pretty good user interface. And I guess the bonus in these simple models compared to the simple guidance is you can consider some site-specific factors such as enclosures or diked areas, certain areas that you're dealing with, etc., like whether you're in an urban environment or rural environment, etc. All right, but nevertheless, there are still some disadvantages to simple models. There are a little bit of nuances in using some of the softwares like Aloha. If you're working with a substance that is not in the general list, you'll have to manually add the substance and include all of the chemical and physical properties of the substance, which may not be very easy to find. A lot of times, not even the SDS will be able to provide all of those information to you. Things like heat capacities and specific heat, things like that will be difficult to find. Sometimes even on the SDS, it's not there. And similarly to the simple guidance, it is still likely to give conservative results because it is, at the end of the day, a simple computer model, and the results will be more conservative and may not be realist. In some cases, it might not be true to the exact release, I guess, that how far exactly it will go. It will kind of take like a conservative take on it and be further than what could actually happen. There's also issues like how these models may not accept all of EPA's required assumptions. We'll go over those assumptions in a moment, but sometimes it won't really take their required assumptions on, say, the weather conditions and the wind speed and things like that. So that's something to kind of keep in mind too. If that issue does arise, you might have to consider different approaches. And like I said before, it may not include chemical-specific data, so you'll have to maybe manually input that in or consider other options or etc. Then also it may not address all consequences. And this is, say, your probably say you have a toxic liquid that evaporates from a puddle into toxic gas and whatnot. It may not be able to really address that in detail. The most it can do is from their assumptions, they will give you a distance of impact. So if you're trying to do a specific modeling or a modeling of a specific consequence of the release, it might not always be available. So there's the simple computer models. Next is complex computer models. Usually these are commercially available models that are developed from different third-party companies and whatnot. And these you most likely will have to pay for them. And some of the advantages of that is it may address a variety of scenarios, so you have more flexibility in how you want to develop your scenario. And some of the maybe factors that you want to input, perhaps they have more options in that. Like I said, it may consider many site-specific factors, so that's what we were just talking about earlier. But the disadvantages is it could be very costly. These are third-party developed programs, and obviously they will charge you a certain amount of charge. Maybe costly, and it may also require a high level of expertise and understanding of the chemical. So there may be a lot more options that you have to tweak to reach the result that you want, which sometimes could actually skew from the reality if you're not very familiar with the program, or if you may not have the high level expertise to run an accurate model. All right. Lastly, there's a calculation method. An example of that is the quote-unquote yellow book, such as the Netherlands or TNO. The advantages is lost cost, no computer requirement, so you're working with another booklet using the calculation approach. But the disadvantages to this is now you're doing everything manually by hand, quote unquote by hand, but you're doing everything manually. So now you may require expertise to apply the appropriate methods, and you may also need to develop a variety of data to use for calculation, which may not be too accurate if you're not doing it correctly. And so these are the various approaches. Usually simple computer models are the most go-to for modeling. The RMP comp or LOHA typically will have every common regulated substances, so you should be good to go if you go with the simple computer models. Now, next off is what we were talking about just before, the EPA's assumptions or parameters that they require for modeling the worst case offsite consequence analysis. So first, starting with endpoints. For any toxic substances, use the endpoints that is specified in Part 68, Appendix A, list of substances. And for flammable substance, use the endpoint of an overpressure 1 psi for vapor cloud explosions. Next is wind speed and stability. Use 1.5 meter per second and F stability class. This is defined as moderately stable conditions. And if you use Aloha, it will actually separate the stability class by the letters. So you can select the F stability class when you want to model a worst case release scenario. Next is ambient temperature or humidity. So use the highest daily maximum temperature during the past 3 years, and to use average humidity for the site. And you can find these information simply through Google. If you search any of the weather engines, obviously reliable weather engines, you should be able to get these data. Next is the height of release. For a toxic substance, assume a ground level release. For topography, use urban or rural topography as appropriate, depending on the location of your facility. Next is dense or neutrally buoyant gases. There are tables or models used for dispersion of regulated toxic substances and must appropriately account for gas density. So This is really only specific to dense or neutrally buoyant gases, and in most cases it won't apply. But when it does, just make sure your model or your table accounts for that gas density. All right, and lastly, the temperature of released substance. So for liquids that's other than gases liquefied by refrigeration, make sure you use the highest daily maximum temperature based on data for the previous 3 years, or at the process temperature, whichever is higher. So perhaps your highest daily maximum temperature in the previous 3 years is, say, 110 Fahrenheit, but your process is operating at 240 Fahrenheit, then you use the 240 Fahrenheit as the temperature of released substance. All right. Also assume gases liquefied by refrigeration at atmospheric pressure are released at their boiling points. So you want to assume at their highest or at their boiling point, and assume that they come out as gas. Right? Next, we have the assumptions or standardized parameters for the alternative case release scenarios. So first, starting with endpoints. For toxic substances, the same. Still use the endpoints specified in Part 68, Appendix A. But for flammable substance, use the following endpoints. The overpressure 1 psi for vapor cloud explosions, radiant heat of 5 kilowatt per meter squared or equivalent dose for fireballs or pool fires, and lastly, the lower flammability limit, LFL, for vapor cloud fires. Next is wind speed and stability. Use the typical meteorological conditions at your site. You can, again, find this in most weather engines. Next is ambient temperature or humidity. For your alternative release case, use the average temperature for the site instead of the highest over the 3 years. And then same, use the average humidity for the site. Next is height of release. In the case of an alternative release case, the height may be determined by the release scenario itself. So it will be dependent versus worst case, you're always assuming ground level for toxic substance. Next is topography. Same idea, urban or rural, depending on where your facility is located. Same with dense or neutrally buoyant gases, just making sure either the tables or the models you use accounts for that density difference. And lastly, temperature release substance at a process or ambient temperature that is appropriate for the scenario. So it's also scenario based and not always based on the highest temperature of either the environment or the process. Just more realistically, your alternative scenario, what kind of temperature the substance will be exposed to or will be in when the release occurs. So yeah, pretty straightforward. We're pretty much at the end of the webinar, but before we wrap up the topic, we will go through a few Q&As to help us identify or resolve any questions that we might have. I picked a few interesting questions, and if this happens to be your question, that'd be great. If not, I hope this will at least provide some clarification on the regulatory requirements. So firstly, under the Risk Management Program regulations in 40 CFR Part 60A, if a Program 1 process contains a threshold amount of both a regulated toxic substance and a regulated flammable substance, should a worst-case release scenario be analyzed for each of the substances in the process? Yes, a worst-case release scenario must be analyzed for each regulated toxic and flammable substance above the threshold. This analysis will serve two purposes. First is to demonstrate that no release from that process will reach a public receptor. And second is to determine the one worst possible worst-case release scenario that results in the greatest distance to an endpoint. And that one must be reported in the RMP. For program level 1, like we said earlier, you will only need to report the one worst case release scenario that has the greatest area of impact, or in another word, greatest distance to an endpoint. Meanwhile, the other one, although you've done a worst case release scenario for it to prove that it won't go offsite, you do not have to report that one. You only need to report the one that has the greatest distance to an endpoint. Next, as a part of the hazard assessment requirements in 40 CFR Part 68, Subpart B, I must analyze worst case release scenarios and document certain analysis in my risk management plan. How many worst case release scenarios must be analyzed, and how many analyses must be specifically documented in the RMP? So, in order to accurately determine which worst case release scenarios should be specifically documented in the RMP, the owner or operator may need to analyze the worst case release scenario, i.e., determine the scenario with the greatest distance to an endpoint for every cover process. If any particular cover process contains more than one regulated substance in excess of a threshold quantity, worst case release scenarios involving each of those substances may need to be analyzed. Also, in order for any process to be eligible for Program 1 requirements, the owner or operator must demonstrate that the worst case release from that process will not affect any public receptor. A worst case release scenario analysis must therefore be reported in the RMP for each Program 1 process. If a Program 1 process contains more than one regulated substance in excess of the appropriate threshold quantity, the documented analysis should be for the release scenario involving the substance that would result in the greatest distance to the endpoint. But for Program 2 and 3 processes, a single worst case release scenario analysis may be documented to represent the worst of all scenarios, i.e., the scenario resulting in the greatest distance to an endpoint. From cover processes containing regulated toxic substances, and a single worst case release scenario analysis may be documented to represent the worst of all scenarios involving regulated flammable substances. Additional worst case release scenarios must, however, be analyzed and reported for Program 2 and 3 processes if worst case releases from other cover processes potentially affect public receptors that is different from those affected by the worst case release scenarios. Now the next question. As required by 40 CFR Section 68.25 for Program 2 and 3 processes, a stationary source owner must analyze the release scenario that results in the greatest distance to an endpoint. Does the greatest distance to an endpoint refer to the greatest total distance from the process, such as a vessel or pipeline, or to the distance beyond the stationary source boundary? The greatest distance to an endpoint will ultimately refer to the distance beyond the stationary source boundary. When selecting a worst-case release scenario, the stationary source owner or operator must first evaluate potential releases from all Program 2 and 3 cover processes. Each release is modeled as a circle with its center at the process and with a radius equaling the distance to the endpoint concentration. The owner or operator must then choose the scenario that results in the greatest distance to an endpoint. If a scenario with a smaller overall distance to an endpoint, however, could result in a greater distance to an endpoint beyond the stationary source boundary, for example, if a process is very close to the facility boundary, it must then be chosen as the worst case release scenario. Next, for the worst case and alternative release scenarios of an underground storage tank, should I consider any impact on groundwater, drinking water, or soil? So the answer to this question is no. As part of the worst case and alternative release scenarios, you need to first define the offsite impacts to the environment by listing the environmental receptors that are within your impact zone. Environmental receptor is defined at 40 CFR Section 68.3 as natural areas such as national or state parks, forests, or monuments, officially designated wildlife sanctuaries, preserves, refuges, or areas, and federal wilderness areas, which could be exposed to an accidental release. You only need to list the environmental receptors and not to speculate what specific damage could occur as a result of an accidental release. Nevertheless, you should consider impacts on the groundwater, drinking water, or soil in both the accidental history for Program 1 eligibility criterion and the 5-year accident history required as part of the hazard assessment. So firstly, for Program 1 eligibility, you must not have had an accidental release of a regulated substance in the past 5 years that caused any response or restoration activities for an exposure of an environmental receptor. An accidental release that led to response or restoration of soil or groundwater of an environmental receptor, such as a park, would make a process ineligible for Program 1. For the hazard assessment 5-year accident history, environmental damage is not limited to the defined environmental receptors. Events where there is an unknown or events where there is any known environmental impact of any kind, such as fish or animal kills, lawn, shrub, or crop damage, must be included in the history. Therefore, any known damage to underwater or soil must be reported in the 5-year accident history. Next question. The owner or operator of a stationary source covered by the Risk Management Program regulations must conduct a worst-case release scenario analysis as part of the required hazard assessment. The worst-case release is defined as the release of the largest quantity of a regulated substance from a vessel or process line failure that results in the greatest distance to an endpoint. If a release from the process containing the largest quantity of a regulated substance would result in a shorter distance to an endpoint than a release from a smaller process, which scenario would be considered the worst-case release? So the answer to this question, firstly, to start with, the worst-case release is the scenario that results in the greatest distance to an endpoint beyond the stationary source boundary, the definition we had before. EPA recognizes that there could be release scenarios in which a smaller process could generate a greater distance to an endpoint than a release from the largest vessel or pipeline. The regulatory language at 40 CFR Section 68.25 subsection H clarifies that a scenario involving a smaller quantity of regulated substance handled at a higher process temperature or pressure, as well as a scenario involving a smaller quantity located closer to the stationary source boundary, may in fact result in a worst-case release. Alright, we're at the end of our webinar. Thank you very much for listening. For any questions regarding the webinar, please feel free to contact me at joyce.shen@rmpcorp.com. For any questions regarding the services RMP provides, please feel free to either contact me or call our general line at 949-682-0123 or refer to our website www.rmpcorp.com for more information. Our website includes descriptions of the services we provide, as well as links to previously done webinars and informational handouts which we referred as tech tips. If you would like to take a quick look at the previous webinar I did in regard to the CalArp, RMP, and PSM program development, please feel free to refer to the website as well. Once again, thank you very much for listening and have a great rest of your day.